Hello, fourth graders and fourth grade families. This is Mr. Christofferson again, hopping on here to make a video to talk about dividing using the area model. And this is a new strategy that is way different from how typically we approach a division question, where we think about setting it up with 67 divided by 4 and going through that process. One of the advantages to using this strategy is it relies heavily on our sense of multiplication. And in my opinion, it's a little bit more kid friendly because we're not thinking about having to drop numbers repeatedly, and it's really, really advantageous when we get to larger numbers. So I'm going to show you some of the basics in thinking about a division question and how to use the area model. So I'm going to start off with just the basics with a 2-digit number divided by a 1-digit number, and that would be 67 divided by 4. So because I'm dividing by 4 here, right away I want to think about some of my basic facts. So I know 4 times 1 is 4, and using my knowledge about powers of 10, I certainly know that 4 times 10 is 40, and I know that 4 times 100 would be 400. Additionally, I could kind of build this out a little bit more and think about, maybe I'll use a new color to separate it. I know that 4 times 2 is 8, which means that 4 times 20 would be 80, and 4 times 200 would be 800. Now, we're not going to be using these larger numbers today, but in the second example that I show, these larger numbers and kind of building off of our basic facts will really come into play here. So with the area model, we set it up by drawing a large kind of horizontal rectangle there. And I put the number that I'm starting with, my total or my dividend, in the inside. So I have 67, and I put what I'm dividing by, or my divisor, on the outside. And what this model is showing is just like how we can use repeated addition to multiply, we can use repeated subtraction to pull out equal groups. And we're going to be pulling out equal groups of 4 out of our total, or out of 67, and kind of work our way down and thinking about this idea of taking out equal groups. So if I'm looking up here at my basic facts, I know that I can take out at least 10 groups of 4. Because when I have 10 groups of 4, my total is 40. So what I'm going to do here is I'm going to take out 10 groups, and I put a little 10 right on top. And when I take out 10 groups of 4, I know that I'm subtracting out 40. And it leaves me with 27. Okay? So what I'm going to do is I'm going to draw a line to kind of segment it and put this 27 up at the top. And that's going to be my new total that I'm thinking about how I can, or how many groups of 4 I can pull out of 27. So now I know, being a rock star with multiplication, I know if I skip count by 4, I have 4, 8, 12, 16, 20, and 24. I can take out these 6 groups of 4, and that's going to get me pretty close to 27. So I'm going to take out another 6 groups. And here, I'm going to go over this in brown just to kind of stay consistent. When I take out 6 groups of 4, I'm going to be subtracting out 24. And that leaves me with 3, and 3 would go back up to the top. And I know that if I just have 3 left, I cannot make a group of 4. So now is the time where we think about where our answer is hidden. And if we want to think about how many groups I've taken out, my first step I took out 10, and my second step I took out 6 groups, which is going to give me a total of 16 groups. And what was left over is 3. So that's a quick bare bones look at this idea of an area model where we're taking out equal groups. So now we want to step up the complexity a little bit, and we're going to use a 3-digit number where we can kind of utilize these larger numbers that we're going to be pulling out. Okay, so my next example question is going to be 712 divided by 6. So again, because I'm dividing by 6, I want to start thinking about my basic facts of 6. So again, I know 6 times 1 is 6. I know 6 times 10 is 60. And I know 6 times 100 is 600. So again, I want to build that area model, a large rectangle. I start with my total, or my dividend, inside the box. I have 712, and what I'm dividing by on the outside. So now I want to be asking myself, how many groups of 6 can I pull out of 712? And utilizing our basic facts here, I know I can pull out 100 groups of 6, and it's only going to give me 600. So that's a great place to start. So I'm going to try to pull out 100 groups. And when I pull out 100 groups, 100 groups of 6 would give me 600. And I'm left with 112. I'm going to put that into my next column here, and I'm starting with 112. Now, I know I can't take out another 100 groups of 6 because that would be 600, and 600 is way bigger than 112. But I do know that I can take out at least 10 groups of 6. So I'm going to try taking out another 10 groups. And when I do that, I'm going to be taking out 60, because 10 groups of 6 is 60. And I'm left with 52. Okay, we can go ahead and finish my subtraction, be a little bit more neat, and here I have 11 minus 6, which is 5. Again, that total goes into the next column. And I repeat the process again. How many groups of 6 can I take out of 52? And in room C5, we have a little rhyme that we like to reference when we're talking about 6 and 8. And we say that 6 and 8 went on a date. How many times? Well, that would be 48. And so having those little rhymes and knowing my basic multiplication facts will allow me to easily know that I can pull out 8 groups of 6, and that's going to give me a total of 48. And here when I subtract, 2 minus 8, I can't do it. We say more on the floor. We need to go next door and borrow. I'm going to give 10 to the neighbor, so now I'm at 12. 12 minus 8 is 4. And 4 minus 4 is 0. If you run out of room, you can always add some extras. So 4 is going to go up to the top again, and I'm going to repeat this process over and over. But if I have 4 left, I know that I cannot make a group of 6. I have 1, 2, 3, 4. There's no way I can make a group of 6. So again, now we need to look at how we can find our final answer. I started out by taking out 100 groups, then I took out 10 groups, then I took out 8 groups. So that would be 118 if I'm putting those together by place value. So 712 divided by 6, I was able to take out 118 complete groups, and there were 4 left over. Okay. We're going to do one more and stepping up the complexity even more and go into a 4-digit number. So we're going to start with the equation 1,537, and we're going to divide by 3. Okay. Again, because I'm dividing by 3, I want to start thinking about my basic facts of 3. I know 3 times 1 is 3. 3 times 10 is 30. 3 times 100 is 300. Now, in the previous 2 examples, I was multiplying. When I did basic facts, I was doing 3 times 1, 3 times 10, 3 times 100. 3 times 1, 3 times 10, 3 times 100. But if you think back to that first example, I did times 2, times 20, times 200. And I'm going to use that same strategy here. But as a smart mathematician and knowing my basic facts, I know that 3 times 5 will give me 15. And I'm starting to think about this idea of adding on zeros. So I'm going to jump ahead and think about, if 3 times 5 is 15, well then I know 3 times 50 is 150. And I know 3 times 500 is 1,500. And right away, I know that that number is definitely going to come into play here because I'm at 1,537. So my answer is going to be pretty close to 500. And let's see if I'm correct. So I'm going to build my area model, big long rectangle. 1,537 goes inside. 3 goes on the outside. So looking at which of these equations is going to come in handy, my eye is definitely looking over here, where I can take out 500 groups, and that would be 1,500, and I'm left with 37. Put that up to our next section. Now I'm deciding where to look. Well, this one's going to come into play 3 times 10. So I'll take out 10 groups. Again, 10 groups of 3 is 30. I'll subtract, and I'm left with 7. Goes to my next column. Oh, I'm getting ahead of myself. That's a 7. And so I'm thinking about 3 groups of 2 is 6, and 6 is pretty close to 7. So I'm going to take out 2 groups, be left with 6. 7 minus 6 is 1. Looking at my final answer, I have 512. And what was left over? This one. So again, what this strategy is building off of is a number sense. And what I mean by that would be thinking about multiplication. Thinking about how we can use powers of 10, powers of 100 to access larger numbers when we divide. It keeps things a little more organized, and when we have these larger equations, I notice a lot of students will, if we had something that looked like this, students will get confused on, well, how many times can 3 go into 1? I'm not sure, do I put a 0 there? And it just is a little more kid-friendly, and this whole process can be really repetitive and students can get confused. And the thing with the area model is this idea of building off of addition and multiplication. Repeated addition is the same as multiplication. Here we're utilizing repeated subtraction as a form of division. Thanks for tuning in, and hope that became a little bit easier. Families, you can always look for or always create extra materials, extra questions just by rolling dice, pulling out playing cards, making a division question, and having your student try the area model. Thanks for watching.